Hello everyone. In this video we will see how we can use the gamma function to evaluate the integrals. But before doing that, let's learn how we can prove that gamma 7 equals to 720 and this expression here equals to pi over 64. So let's do this first. So in the previous video we learned that gamma n plus 1 equals to n factorial. So gamma 7 can be written as gamma 6 plus 1. So here our n is 6. Since gamma n plus 1 equals to n factorial, gamma 6 plus 1 must be 6 factorial. And we know that 6 factorial is 6 times 5 times 4 times 3 times 2 times 1, which equals to 720. This was easy. So now let's move on to this second question. So our next formula was gamma n plus 1 equals to n gamma n. So for this problem we can use this formula here. So we are given gamma 3 over 2 times gamma 5 over 2 over gamma 5 equals to gamma. So gamma 3 over 2 is same as gamma 1 over 2 plus 1, and gamma 5 over 2 is same as 3 over 2 plus 1, and gamma 5 is same as gamma 4 plus 1. So here our n is 1 over 2. So using this formula here, gamma n plus 1 equals to n gamma n. So our n is 1 over 2 times gamma n times, here our n is 3 over 2, so we can write 3 over 2 times gamma 3 over 2 divided by, and here we can use this formula. So gamma 4 plus 1 is 4 factorial equals to 1 over 2 times gamma 1 over 2 is square root of pi times 3 over 2, and gamma 3 over 2 is same as gamma 1 over 2 plus 1 over 4 factorial is 24. 1 over 2 times square root of pi times 3 over 2 times 1 over 2 and gamma 1 over 2 over 24. So 3 times 8 is 24, and 2 times 2 times 2 is 8. 8 times 8 is 64. So we will get 64 at the denominator, and we have square root of pi, and this gamma 1 over 2 is same as square root of pi, so we will get pi. Now after doing this we can move on to evaluating the integrals using the gamma function. So now let's do the integrals. So our first integral was integral 0 to a x to the power of 4 over the square root of a square minus x square dx equals to 3a to the power 4 pi over 16. So we need to prove that this integral here equals to this using the gamma function. The first step we can do is put x equals to a sine theta or cos theta. So whenever you see this a square minus x square or 2 square minus x square or 9 minus x square, where 9 is 3 square, you have to use x equals to a sine theta. In this case our a is 2 and in this case our a is 3. So using this substitution, now differentiate both sides with respect to theta, we will get dx equals to a, and the derivative of sin theta will be cos theta d theta. Now we have to change the limits. When x equals to 0, theta equals to 0, and when x equals to a, our theta equals to pi over 2. So our integral, let it be I equals to 0 to pi over 2, and in place of x to the power 4 we can write a to the power 4 sin theta to the power 4 over a square minus, and in place of x square we can write a square sin square theta and in place of dx we can write a cos theta d theta. Equals to integral 0 to pi over 2 a to the power 4 sine to the power 4 theta over, so we can take a square common here, a square 1 minus sine square theta times a cos theta d theta equals to integral 0 to pi over 2 a to the power 4 sine to the power 4. So this expression here results in a times, so 1 minus sine square theta is cos square theta, and that square and this square root will cancel and we will get cos theta, and here we have a cos theta d theta. Let me clear this. So we have I equals to this a and this a will cancel, this cos theta and this cos theta will cancel, and we are left with a to the power 4 times integral 0 to pi over 2 sine to the power 4 theta d theta. So to integrate this, it has a very long process, but we have learned in gamma function that integral 0 to pi over 2 sine to the power m theta times cos to the power n theta d theta equals to gamma m plus 1 over 2 times gamma n plus 1 over 2 over 2 times gamma m plus n plus 2 over 2. We know that anything to the power 0 is 1. So this expression here, sine to the power 4 theta, sine to the power 4 theta is same as sine to the power 4 theta times cos theta to the power 0, because this expression is 1 and sine to the power 4 theta multiplied 1 is sine to the power 4 theta. So we can write I equals to a to the power 4 integral 0 to pi over 2 sine to the power 4 theta times cos to the power 0 theta and d theta. So we got our m equals to 4 and our n equals to 0. Now we can plug this value into this formula and we can evaluate the integral. So equals to a to the power 4. Now gamma 4 plus 1 over 2 is 5 over 2 times gamma. So we have n equals to 0 here. So 0 plus 1 over 2 is 1 over 2 over 2 times gamma. M is 4. 4 plus 0 plus 2 will be 6. 6 over 2 will be 3. A to the power 4 over 2. So previously we learned how to evaluate this type of problems. Now gamma 5 over 2 is same as 3 over 2 plus 1, and gamma 1 over 2 is square root of pi over, and gamma 3 is same as gamma 2 plus 1. So equals to a to the power 4 over 2, and our gamma n plus 1 is n gamma n, and we have square root of pi over, and gamma n plus 1 is same as n factorial. So let's go here. I equals to a to the power 4 and 2 factorial is 2, so 2 times 2 is 4, and multiplied with this 2 we will get 8, and in top we have 3. So let me write 3 a to the power 4 over 8, and gamma 3 over 2 is 1 over 2 times gamma 1 over 2 times the square root of pi equals to, now multiply 8 times 2 is 16, so 3 a to the power 4 over 16, and Gamma 1 over 2 is square root of pi. Multiply this with square root of pi, we will get only pi. So I think this completes our proof. Our integral 0 to a x to the power 4 over the square root of a square minus x square dx equals to 3a to the power 4 times pi over 16. So this video is already long enough, so we will continue other integrals in next video. So thank you.